All right, on the right-hand side of the thing in the upcoming thing says Molarity Kool-Aid Lab. We're going to do this today, but in the materials section, there's a new folder. This is Unit 9. It's called acids and bases, but really acids and bases are also solutions. We've just done some stuff about right, basic, well, the basics of concentration, and concentration is the unit, or is the concept we use to measure amounts of acid and base in a solution and pH. So anyway, this week of 426 to 420, 430, that molarity worksheet number 2, I gave it to you on Friday, and if you didn't finish it, you want to finish it and work on it today. We're going to go over that tomorrow. So there's time in class today to do that too. And this, we're going to do a lab on molarity of Kool-Aid. So you picked up this thing on your way in, says honors chemistry, molarity, concentration, activity. If you're remote, let me see. We're going to put, well, I'll show you where this is. In the folder, I could have just gone back. That would have been faster. Here it says like molarity of Kool-Aid. Remote and absent students use a copy attached data filled in to complete the assignment. So when you click on this, it says remote Kool-Aid lab with data. So there's some data that students will collect in class today. And this is similar data in terms of mass of the cup and the mass of the cup with Kool-Aid and mass of sugar and so on and so forth, that you could complete the calculations. So only if you're remote, these are values that you could use that are pretty good values. So, but let me give you a sense as to how this all works, whether you're remote or you're here. I'll draw like some pictures and whatnot. So the idea is that if you make Kool-Aid, you're making a solution, and there's a bunch of different components of that solution. So generically, you got some water in a cup. So the solute, I haven't had my coffee yet. Solute. The solute is water. I don't know why I just wrote that. The solvent is water. So you got the solvent is the thing that you got the greatest quantity of. You got a whole bunch of water in the solution. What's on the tables, there's a jug, and that jug has some Kool-Aid, but it's just the like, you know, you get Kool-Aid a bunch of different ways. You get the pre-made Kool-Aid where it's got the sugar and the stuff all together. You just dump it all in. This is the packet kind of Kool-Aid. So when you take just a packet of Kool-Aid, the packet just has artificial coloring and flavoring. So when you take the packet of Kool-Aid, just the thin little packets, and you put that in, you have coloring and some flavoring. It's what gives the Kool-Aid its color, and the flavor is a totally separate thing. There's also color and flavoring. Those two things are solutes. But if all you do is put the coloring and flavoring in the Kool-Aid, I don't know, it's not so great tasting. That's not how Kool-Aid's supposed to be. So you already have some coloring and flavoring in the Kool-Aid jug. So that's like the jug on the lab tables. You're going to also add sugar to it. So besides the packet, you've got some sugar. Maybe this like represents some sugar, like a cube. And the sugar is also a solute. Because anything that is in a smaller quantity in the solvent is a solute. So you've got a number of solutes. You got coloring, and the artificial coloring is oftentimes a number of different coloring agents. You got some artificial flavor, maybe 1 or 2 or 3 different flavors, and then you got the sugar. So there can be many solutes in one solvent. So here's the thing you want to know. We want to know what is the concentration in molarity of Kool-Aid when you have an appropriate amount of sugar. So if you have not enough sugar, it tastes like weak. And if you have too much sugar, I don't know, it'll settle in the bottom and it's just kind of too sweet. But I mean, some people just like to put crazy amount of sugar in. Whatever. There's an appropriate amount of sugar that makes it taste good. So what you want to do first is get yourself a cup, just an empty cup. And if you find the mass of the cup, then you can record that data. You put some Kool-Aid in the cup, just the Kool-Aid with the flavoring and coloring. So you've got some Kool-Aid, that's non-sweetened in the cup. So if you weigh the Kool-Aid in the cup and you weighed the cup separately, you subtract the mass of the cup from the cup with the Kool-Aid, that gets you the mass of the Kool-Aid. Because you don't want to know the mass of the cup. You need to know what's the mass of the Kool-Aid. And then it turns out that the density of Kool-Aid is pretty close to 1 gram per milliliter. So if you find that the mass is like 13.5 grams, because the density is around 1 gram per milliliter, if you go 13.5 grams and the density is 1 gram per milliliter, it's also 13.5 milliliters. But you know that molarity has to be in the unit moles per liter. So this 13.5 milliliters is an appropriate volume to either measure or derive in lab, but it's not appropriate for calculating molarity because molarity has to be in moles per liter. So the volume in milliliters has to be converted into liters. Now, you could just find the volume of Kool-Aid in a graduated cylinder, but you can drink this Kool-Aid when you're done with the experiment, and it's totally not okay to put Kool-Aid in a graduated cylinder and then drink it from that because you have no idea what used to be in that graduated cylinder. So we don't do that. Instead, Dixie cups, totally safe. That's why we're going to find the mass of a liquid instead of the volume of a liquid, which is normally what you do. Now, you got a known mass of Kool-Aid, therefore a known volume, and you can convert that volume into liters. So convert that into like so many liters of Kool-Aid. So you know the volume of Kool-Aid. That liters is the volume of the solvent. The moles is the moles of the solute, and the solute you're going to add is sugar. So the sugar itself, there are many different sugars. So sugar is a generic word we use for any organic uh, molecule that is an ose. So you know there's a bunch of different sugars like fructose, glucose is the sugar your body runs off. The sugar we add to the Kool-Aid is sucrose. And sucrose has a formula C12H22O11. It's a pretty large molecule and it has a much higher formula mass than most chemicals that we've worked with in this class so far. And we haven't done a thing about how you name that chemical, but that is the formula for sucrose. So what you want to do is add some sugar uh, to the sucrose solution, but you got to keep track of how much sugar you use. And the problem is if you have to weigh out little bits of sugar all the time, it's annoying to figure out the total mass of sugar by weighing out little portions of sugar. So a smarter thing to do is if you take a cup with sugar, so here's like sugar in a cup, and you weigh the sugar in the cup. So let's say the sugar and the cup has a mass of like 15.2 grams. You want to take some sugar out of that cup and add it to the Kool-Aid in small portions and stir it up until you think you've got an appropriate amount of sugar. And then if you reweigh the sugar in the cup and you find that its mass is now like 4.7 grams, then the mass of sugar you used must be the difference between the 15.3 grams, which is the sugar in the cup you started with, and the mass of the sugar in the cup whenever you're done. So that way you can, keep on taking sugar out of the cup and add it to the Kool-Aid. And yeah, if the spoon you use gets like wet, it's going to get sugar stuck to it, but that's okay because the sugar, if the spoon is wet when you put it into the sugar, it's going to pick sugar up out, and then when you put it in the Kool-Aid, you're going to transfer all the sugar into the Kool-Aid. You don't have to worry about the residue of sugar being left on the spoon itself. So this is an unusual technique, but generally the plan is we oftentimes do this process of weighing by difference. You find a mass of something before, you find a mass of something after, the difference must be how much you used. Similarly, when you weigh the cup and you weigh the cup with the Kool-Aid, the difference between the cup with the Kool-Aid and the cup by itself must be the mass of just the Kool-Aid. So anyway, once you find the difference in the mass of the sugar in the cup, The difference between these gets you like how much sugar you used. You can use the formula mass of sucrose along with the mass of the sugar you used to calculate how many moles of sugar you actually used. So this is the moles of sugar, the sucrose, and this is the volume of the, I guess you could say the unsweetened Kool-Aid. You need a pretty good volume of sugar to be able to taste the sweetness, but artificial flavoring, there's a whole lot less volume you need. So like you can buy, the little packets of like lemonade, and those have an artificial flavoring in them because a little bit goes a long way. And it turns out there's a little bit of a trick. Like when you get if you have a packet of like Equal or Splenda or Sweet and Low, most all of the volume of what's in that packet is just a flavorless filler. The sweetener is actually a very small portion of that volume, but we're so used to like doling out sugar, I guess, that you need a bigger volume of the filler. And similarly, if a packet of like Equal or Sweet and Low or Splenda or whatever had only the sweetener in it, it would be just a tiny little bit. You might not even be able to get the stuff out of there because it always leaves a little bit of residue behind. So artificial flavorings can actually be very intense in flavor, and artificial sweeteners are also like really sweet to your taste as compared to that of sugar. So, but sucrose, you can get sucrose from all kinds of stuff. You can grow sugar cane. Um, Beets are actually a common way that sugar is derived from sugar beets. But a lot of the sugar we use is refined cane sugar. All right. So anyway, the paper kind of walks you through the steps, but in the end, your goal is to determine what's the concentration of your sugar in moles per liter or in molarity, and then do that, and then do the worksheet number 2 if you didn't finish that yet, and we'll go over that tomorrow, I guess. That sound good? All the materials are on the lab table. Everything is safe to eat and drink, and you don't need goggles as long as you don't like put in anything else besides what you need.